Press record here. We're looking at 4 Bravo identified basic facts about tropo theory. Some of this you've seen in block 4, but it's going to expand upon it. Remember that you have 70% on the block test. That is, you got to answer 28 of the questions correct to pass. Again, you got to really study for this test. This test, if you know, you may get some intel on it as far as how it's worded, but this is a true college test. No holds barred. I have never seen a test that is so good at testing your knowledge. Now, remember, we're just dealing with basic facts about most of this information. We're not going to have you do calculations. We're not going to request that you analyze a circuit. We're just going to ask you things about that's very basic. So let's take a look. Again, the FSC application. Big thing is beyond line of sight. This one is using the troposphere itself. So when we take a look at the troposphere in tropo theory, we're going to cover tropospheric communications, antenna terms, and tropospheric antennas. So we have troposcatter, and you guys probably have heard this back in block 4, but I call it over the horizon. Well, a lot of people say, no, it's beyond line of sight. Well, that's true, but we got to separate HF out from tropo. Tropo's in one set of frequency ranges versus HF in a different frequency range. I can tell you that HF will go a lot farther, and in some rare cases around the world, if the conditions are excuse me, if the conditions are ideal. Tropo, not so much. Not so much. It is still considered a line of sight or beyond line of sight. I call it over the horizon. Utilizes a troposphere. The idea is that word reflect is actually should be refract back down to Earth. You can see in this diagram that most of the tropo that we generate goes right out the atmosphere. Very little of it gets refracted back down, and this is where the high gain antennas come into play. So the idea is to get it just beyond that horizon and then to get it refracted back down to Earth. Here's a typical tropo system. Powers between 300 to 50,000 watts. Frequency ranges from about 350 megahertz to 8 gigahertz. There is some conditions where it will go down as far as 50 megahertz. But that's one of those, again, conditions got to be really good for that to happen. But when we deal with frequency ranges of 350 megahertz to 8 gig, these are consistent where you can get calm. Range up to 595 miles fixed, and it also depends on what credible website that you go to. It will be anywhere from about 580 to 610. I don't know why they chose 595. No idea. Might be one of the older pieces of equipment they pulled the 595, but it still fits within that range. That's fixed. And you're still dealing with about 50,000 watts, but with tactical, up to 300 watts, but you're only going to get 150 miles. So the idea behind tactical is you don't want to create a huge radiation signature that the enemy can pinpoint and take you out. Next up, we have scatter volume. It's also called the common volume. That's that area where it gets refracted back down to Earth. The big thing about it is the antennas. You got to have a very highly directional antenna to get it up to the tropo, and then you have to have a very high gain antenna to receive it. It's normally on both ends. It's called reciprocity. Tropo uses what's called a diversity system. Now, when they say blurring, they're talking about where the signals cross over to each other. Let's look at polarization. If you transmit vertically, will you be able to receive horizontally? Throwing the question out there. Anybody? No. Why? Because it's a linear polarization. Now, when you get to the tissers, and you're going to see this, one end is going to transmit vertical, the other end is going to be transmitting horizontal. That's to prevent this blurring, so you don't get a cross of these signals. And you're going, well, how in the heck does it receive? Let's go to the NIVIS. Is the NIVIS vertical or horizontal? Yes, it's both. It's both vertically and horizontally. If you look at the tisser when you install your waveguide, you will notice that the antenna, or at least the opening, will be at a 45-degree slant. When you are at a 45-degree slant, you can receive both horizontally or vertically, no matter what the received signal is. So the idea here is to prevent our transmit from crossing over to each other and interfering. Now with angle, this has everything to do with how you do azimuthal, which is 360 degrees, and elevation. They both have to be at the same angles. When you come right down to it, when you look at the scatter volumes, they will be different, but you should be able to, and that's that, what's the name of it in block 4, where it spreads out. It will have some crossover, but the idea is those scatter volumes are still going to be different, but you're going to be on the same angle of everything. Space. Oh boy. With our tissers, jerk 239s, where you're going to be setting it up, you are going to be extremely close to each other. You're going to saturate the front end. You could point the dishes opposite of each other and you'll still get communications, especially in the hallway. I've tried it just to see what would happen. If you're outside and on the side of Jones Hall and you're, from one end to the other, there's a very good likelihood you're still going to make communications. With the space, the farther out you get, that's when the true happenings take place with space. Space being the farther out you get, you now have to start tweaking the signal with your angle. Elevation and azimuthal. So space and angling, and those two go together. With frequency, you're going to notice that when you put the frequencies in your tisser, they're going to be 180 out on the distant end. That's because we don't want to cross over the transmit with the receive and vice versa. So take a look at it. When you get the cut sheet, you'll notice that on that cut sheet that your end is going to be different than the other end. So all 4 of those take in consideration what is happening with your tisser to keep it separate, and you're able to talk to each other without interference. This gives you a better idea between common volume or scatter volume. That's the little area in the middle where things get refracted back down to Earth. Again, you're transmitting and receiving antennas. You can still alternate or change them out. Like your transmitting antenna is also your receiving antenna. And your receiving antenna is also your transmitting antenna. Wow, reciprocity there, eh? Next up. Wow, what have I been talking about for the last couple minutes? Reciprocity. How well your transmit antenna should be able to receive just as well as it can transmit. It's pretty much what it is. Directivity and gain, higher the directivity, the better the gain. Lower directivity, lower the gain. The difference between does everybody know what a Yagi antenna is? So, go ahead. Okay. Well, in block 4, we should have one in each room. It's a very directional antenna, not as directional as a dish, but it looks like a antenna that points in one direction. Unidirectional antenna. Well, that has a high gain compared to a vertically polarized whip antenna, doesn't it? So the better directivity, higher gain. Lower directivity, the lower the gain. Frequency. This is, again, block 4 stuff, to where if you take the electrical length at 3 megahertz, it's 100 meters. That's a pretty long antenna and a pretty long wavelength. If you look at a higher frequency, and let's just say 300 megahertz, you're looking at 1 meter. So the higher up you go in frequency, the smaller the antenna. The lower the frequency you go, the bigger the antenna, hence inversely proportional. Next up, we have something that we call directional antennas. This is more applicable to what we are used to seeing for wide-banded equipment. We're going to look at the horn and the parabolic antenna. The whole idea behind it is we don't want to waste RF energy. We want it to go one way. Horn antenna, we've covered this in block 4. It's the simplest type of directional antenna. It has a flared aperture, and it does use some type of impedance matching when you get the antenna in the rear. We have a parabolic antenna. This one is more designed for microwave frequencies, microwave being the higher end. Size and gain are directly proportional. So the bigger the dish, the better the gain. Okay? We use feed horns. You have a front feed and a rear feed. Most of your DirecTV Dish Network TVs or dishes are front feed. The parabolic antenna is the dish itself. Then you can do either front or rear feed. And the idea behind this is you've got 2 different types. You got a center feed and an offset, and then you got a rear feed, which is 2 different types of what's called Cassegrainian. Let's take a look at each one of these. The front feed, you've probably seen this when you come into Jones Hall, those satellite dishes out there. That's a front feed antenna. We have the front feed offset. Now that one I think is the closest to the gated area. I'm trying to think if it's a TSC 61. The next one we look at is the Cassegrainian rear feed. That's the brown one there that you see. Oh look, it is Jones Hall. Now the interesting part about this one is it bounces off the dish, hits another reflector, and then gets into what's called the front feed, or rear feed, excuse me. Sorry about that. The rear feed, the feed horn. It's on the rear of the dish. Whereas the front feed bounces it from the front off the dish and then out. These can be considered what I call a double shot, which it takes 2 bounces in order for it to go out the dish, or 2 bounces to get back in if you're doing a receive. The Cutler is what we have on the Tisser. They call it a double shot again. It has 2 flat reflectors. Now, if I'm not mistaken, on the 1-foot dishes that you guys will be dealing with, what we call the ping pong ball has been ripped off of it because it's been used so much. And you should be able to see the reflectors. Now, I'm trying to... Let me see if this shows up. Okay, so you see this? This is your waveguide. And what will be on it, there'll be a metal reflector on that side and a metal reflector on that side. There will be right about here and here will be a rectangled hole. And what happens is it bounces off the dish, hits those metal reflectors, and somehow, some way finds its way into those metal rectangle holes and then goes into the rear feed of the radio. This one is considered the narrowest beam width and the highest gain. So there you have it, Tropocom antenna terms and Tropo antennas. This was pretty quick, pretty easy to get through. Any questions? Kool-Aid makes the world go round. All right, so let's do this. Everybody break out their ANGRC 239 tech order, please. We're going to go through the tech order. Oh, come on. Let's do this. Let's go down one. It's a little bit easier to see. Can everybody see that? Okay. I'm trying to make it as legible as possible without compensating having to, make it smaller and go through everything. So everybody have their tech order pulled up? Anybody not have their tech order pulled up? You can say you don't, wait a minute, and all that kind of stuff. What we want to go to is chapter 1. And I'm going to be, everything that's highlighted, you might want to highlight that to give yourselves an idea if you can do it, because this is the same PDF file that I got from you guys. And you can, from what I can see, you can highlight it through the PDF. So you'll see on 1.1.3 types of traffic. There are 3 types of traffic they discuss in here. They have what's called, and I'm reading the first sentence here, in addition, the radio set AN/GRC-239 can carry digital traffic with a 3-volt peak-to-peak conditioned diphase waveform. That is CDI. The 3 volts peak to peak, you're going to look at the front meter to take a look at that if you have a multiplexer to put into it. Why 3 volt peak to peak when most multiplexers are putting out 5? It's to compensate if you've got a long cable run. There are attenuators on the front of the baseband assembly. I know it's going to sound kind of strange when I pop these terms up for you, but you'll get used to it when you start doing lab. That attenuates the multiplexer signal, both input and output. Now you'll notice that underneath of the CDI, it talks about a 0.072 to 4.608 megabits per second. You can also see that it has analog or digital order wire. Order wire is considered our channel, as in it doesn't degrade the mission traffic. Next up, you guys remember putting up CTM15? Well, guess what? You actually have what's called a Jerk 239 mast. And in the dish box that you have. Go ahead, King. Hello? King? You were typing. Yeah, same here. So look at it this way. At least I'm going to send you the links to both of these, and you'll be able to refresh your memory if you're missing part of it. So, thank you. All right, so one of the things that we tell you about the mast is you can put what's called the RF assembly, which is it'll come with the mast, it'll come with the RF and the baseband assembly, but you put the RF assembly on the mast, but you can only put it with the 1-foot dish. And I think the RF assembly is approximately 26 pounds. And you knew how hard it was just to get the AT197 up it. So can you imagine I think the AT197 is about 7 or 8 pounds. But when you're dealing with 25 pounds, man, that's a tough road to haul. It's an upper body workout. Now, also, I'm sorry? Yeah, it's pretty tough. But the baseband and the RF assembly can be mounted on a tripod, or the RF assembly can be mounted on a pole system, and that's with 2 different dishes. Now we have a 1-foot and a 2-foot. You're going, okay, I just got confused. The 1-foot can only go on the 50-foot mast. There are extra cables and extra stakes. Instead of the 1.5-foot stakes, they come with a 2.5-foot stake. And the extra cables is to give you extra support and give you 4 sets of guy ropes. So that wind load is about 70 miles an hour with the RF assembly on top of the mast. Anything beyond that, take it down. You'll toast the mast. Radio, before I get any farther, I forgot to tell you about in 1.1.3. That's my mistake. I got sidetracked. And this is underneath the order wire. It says radio set Jerk 239 can also carry 6.144 megabits per second. This is the most important line in this tech order. It says pseudo NRZ. The word pseudo it emulates NRZ. This is the only place in the tech order that says pseudo NRZ. Back in the early 90s when this was made and put out in the Air Force, just by pulling out or just telling you at the front end that this was a pseudo NRZ, anytime they had NRZ in there, and there's a bunch of places, especially in Chapter 5, they saved 1 page per book that they printed out. When you print out a couple thousands of these, that's money in their pocket. So by just saying pseudo NRZ and the rest of it NRZ, they saved a lot of money. And you're going, well, Mr. Mayor, we're a digital world now. Well, that's true, but this came out back when, probably before you guys were born. So it just goes to show you that back in the day, paper was a big thing. Now, if they needed to change it, they would just go online and send you an update, and you would be able to download it on your I think they're doing tablets now for all your TOs. Is that right there, Sergeant Kennan? Senior Airman Alvarez? Rapoli? iPads. Okay. So it would just take a digital download now. What's that, sir? Going to iPads? I'm not a fan of a tablet. I like paper. Okay. Next up, we look at 1.3.3. And it says the radio transmitter and receiver consists of two weatherproof assemblies that are either mounted as a single unit or separated by 150 foot of cable. When you mount them, just to give you an idea, if you look above me where it says the 3/38 and you look at that picture, that is the tisser. That is the 1 foot dish, the 1 foot gate scenario waveguide with the RF assembly. You can put the baseband assembly right next to it. It comes with a 2 foot cable on it. If you wanted to keep those things separate, just like this is showing you above me, you can put the baseband assembly in a, let's say, a tent or a building and separate it by 150 feet. Now, it says waterproof assemblies. What goes on the front of those assemblies is a shield, and it has gaskets and everything else to help it prevent any water from going in there. Now, that ping pong ball that I was telling you about that covered up the small waveguide, and we've got it ripped off, that's how it keeps the water from getting into the waveguide, is that ping pong ball. You'll see it on the 2 foot waveguide that comes in the satellite or the dish box. Down below that, I got highlighted where it says RF circuits of the receiver are 70 megahertz. Where have you seen that one? Okay. And then the next part of that highlight is radiation of the RF energy is via either a 1 foot or 2 foot diameter antenna. And the installer can set for either horizontal or vertical polarization. It says use of the 1 foot antenna with associated larger beam width simplifies the erection and alignment of the path. So they're telling you, hey, you can use the 1 foot dish for all your alignments, and then you can put the 2 foot dish on it if you want. When we go to 1.4 equipment configurations, it says this is what's packaged for storage or transit. The cases that these are in are called transit cases. I just call them cases. It says when deployed with the 1 foot diameter antenna attached to the RF assembly atop a 50 foot mast. Okay? Heed that. 1 foot antenna, 50 foot mast. You look at number 3 and number 4 in 1.4. It says you can deploy 1 or 2 foot diameter antenna attached to the RF assembly atop a tripod. Okay. And then it says on number 4, when it's deployed with 1 or 2 foot antenna attached to a pole. Okay. So what does that tell you? The 2 foot dish does not get installed when you're putting it on the mast. The reason is it will act like a sail and it will tear your mast up. And we've had antennas break that mast in 2 places a couple years ago. Still have pictures of it. Pretty impressive. This is a picture of a metal case with the baseband assembly and RF assembly. You'll see number 1 and number 2. RF assembly is number 1. Baseband assembly is number 2. This is on page 1-5. You also see where it says a 2 foot jumper cable, handset, power cable, headset, and electronic consoles case. When you scan down like I'm doing, the bottom part, number 8, is the metal case that both the baseband and RF assembly go into, as well as the handset, the 2 foot cable, the power cable, and the headset. Let me caution you about the headset. When you plug it into the RF assembly, sometimes if you don't plug it in the correct way, it will squeal on you. I suggest very highly that you do not have those on when you're doing that. And also do not have them on when you're doing the test tone checks. There is no volume on that headset, only the speaker. Same with the handset. Don't put it up to your ear when you're trying to do test tone. safety precaution. Protect your ears. And here's your 1 foot and 2 foot dish section. Where number 5 and 6, or number 5 is, that's where the cables and stakes to put the mast up. You can see 2 and 3, those are where your waveguides are. Number 4 is where the 1 foot dish is, and number 1 is where the 2 foot dish goes. So this is when you open it up and extend it all the way. This is part of, if you look at number 6, it says the antenna tilt assembly. It does come with a halyard, so when you get it up on the mast, you can use the halyard to twist it to elevation. You can twist the mast assembly to where you can get azimuthal. Preferably get it up the right way and not twist it as much, and then you have to tweak it. But this particular assembly, I think, is in Block 4's room. And of course, the tripod. There is a tripod case with the pan head tilt assembly along with the pan. You'll see number 11 in this particular picture. That's your 150-foot cable. And this just gives you a picture of what it's going to look like when you have both the baseband and the RF assembly. It is connected with a 2-foot cable. This is what the RF assembly looks at. Now, evil laugh, right? The frequency select switch, they're thumb wheels. As a precautionary tale, I will give you information about those two, and it even says it in the tech order here of pay attention to that sentence there. But you'll notice that, and I'm going to tell you the frequency range, which is 14.4 gigahertz to 15.25 gigahertz. What doesn't change on a thumb wheel? Well, the number 1, which is the 14 to 15. That far left number, which is the tens of gigahertz, does not change. So we don't need to turn that thumb wheel. The first thumb wheel on the left-hand side, this is both receive and transmit, you should be able to turn it to either a 4 or a 5. You don't need to turn it to a 6. You don't need to turn it to 6, 7, 8, 9, or 1, 2, or 3. The problem is because people don't realize that some of these thumb wheels are broken. And I think you can only select the 4 in some instances. The last 3, going from left to right, you can change anything on there. But I'm going to caution you on the hundreds of millions of hertz, which is the second dial from left to right. If you change that number outside of the frequency range, because you can, and I said 14.4 to 15.25, well, let's say that number can go to 3. That's outside the range. Right below it, under that transmit frequency, it says channel error. That light will illuminate, telling you, hey, I think my thumb wheels are all screwed up here. I'm outside the range. So just a precaution, please be gentle with those thumb wheels when you get out there. You'll notice that the receive frequency is on the top, the transmit frequency is on the bottom. You'll also notice that over on the bottom left of this RF assembly is a receive frequency again. This is your pre-selector. You got to turn that knob to the frequency that you need to get it to. This is pre-selection. Your receiver frequency is overall selection for the receive side of the house. Always remember, when you get that cut sheet, it'll have the transmit frequency on top. Don't get confused by that. Put it in the transmit frequency thumb dials, which is on the bottom of the RF assembly. So try to keep those two separate. You can see that you have a headset connector there. That's where you're going to plug it in at. Here's 1 foot, the 2 foot antenna. Here's the baseband assembly. There are, in each one of those, your RF assembly has 3 LRUs. The baseband assembly has 5. And it's pretty easy to see 4 of the 5 just by looking at each one of these sections. It says 1, 2, 3, 4. The 5th one is your power supply module, which is on the side. But the only way that you can access it is through number 4. You got to twist all 4 screws on each of that card and slide it out just to get to number 5. So you have what's called the, at the bottom of each one of these cards, you can see OW, which is called the order wire assembly, or LRU. You have a transmitter assembly. You have a receiver assembly. And all of these are called line replaceable units. And back behind number 4, that's your breaker panel along with your power supply. I put on 1.5.2, which is a mast. You can see that the mast is capable of supporting the RF assembly with the 1 foot dish in high speeds up to 70 miles an hour. That's pretty wild for that. What in the world would my... That's weird. Shifted on me for some reason. Tripod again. You have leading particulars. This is in 1.6. Capabilities and limitations. That's where the bulk of the information is if you need to look it up. So, I haven't been lying to you. So take a look at the frequency range. You got 14.4 to 15.25 gigahertz. The RF power is 25 dBm or 316 milliwatts. The RF assembly, same thing. Difference is it just gives you an IF frequency of 70 megahertz. And then it shows you the antennas. Now, I want to be very clear on this. The RF output of the RF assembly is plus 25 dB. When you put the 1 foot dish, it goes from 25 to 31. That's a 6 dB of gain. The nominal distance, which is maximum, I do want to point out, look at that sign in front of the 10 miles. That's a less than sign. Don't get confused with, oh, 10 miles. No, it's actually less than 10 miles. How they arrived at that, I don't know. My guess is under the right conditions, it could actually go just a little bit farther. It may not. Then you put scared the crap out of me. All right, the mid-band, the gain, which goes from 25 dBm to 31, that's a 6 dB gain. The 10 miles, that sign in front of it, is the less than 10 miles, meaning that it doesn't quite reach 10 miles. Now, my guess is in the right conditions it could, but why try to go beyond what your scope of the equipment is saying it can do? Was that okay? Okay. The 2 foot antenna. Did my mic freak out or something? Spore? Did my mic freak out or something? Oh, okay. I don't, Discord's like that. If you go to the RF transmission site and you listen to it, it doesn't have it in there. So this is, I think, is a Discord thing when our bandwidth starts getting maxed out. Just letting you know. So when we look at the 2-foot dish, this one goes from 25 dBm to 37. That's a 12 dB gain. You remember doubling the power every 3 dB? Wow. And of course it says that less than sign, which is 25 miles. Installation, there's your 2-foot cable under table 2-1. In 2-8, it gives you man hours. I'm just showing this for gee whiz purposes on this one. When you're in the classroom, you'll be given 45 minutes to set it up and go through all of the checks and procedures. If you're going to put it on a mast, that's a different story. And on a pole, normally you're going to get a cherry picker to do that. Normally that's more of a permanent installation. Oh, look at the warning here. To avoid injury to personnel and possible damage to equipment, do not erect the mast within 100 feet of any overhead power lines. That's normally double the size of the mast. So if the mast is 15 meters, you should look at 30 meters being how high the overhead power cables might be. And of course it has some more stuff about putting up the mast and how it comes off and goes down. Cautions and warnings. Trying to keep this. Again, the installation with the 1-foot or 2-foot antenna on the tripod. There's another 2-foot. So you can see where we have a lot of the 2-foot cables when you're attaching it to a tripod. Ah, yes. Chapter 4, Operation. What we have done, I should say Mr. Miller has done, is he's taking this and pulled out the extract, and you should be able to read it from the notebooks that we will be giving you when you do your test setup. Everything that's in here is on there. There is an extra piece or a cut sheet that goes along with it that tells you your polarization of your waveguide and your transmit and receive frequencies. It'll tell you which ones to choose and what to do it. Again, I cannot emphasize being gentle with the thumb wheels. This is just giving you another overlook of what I just went over on the RF assembly. Again, here's the RF assembly. However, to get to the meat and potatoes of the RF assembly, right here it is, table 4-1, the RF assembly controls and indicators. There's very few items on there that you can check, but it is very important with that thumb wheels. Again, it goes through it a little bit more deeper in how everything works. Now, I highlighted the channel error light because when you get out there setting up your TISR and you got that light on there and you can't make communications, that's a troubleshooting thing for you. Same with the summary alarm. Something's happened between your baseband assembly or your RF, well, between the RF and baseband assembly, or literally the RF assembly. Here is 4-2, which is also your baseband and assembly with controls and indicators. On both things, you have a meter and the selection switch to figure out what is correct and what is incorrect. And there's that baseband test tone. 2.6 kHz on it. It will deafen you if you have your headset on. And table 4-2 goes through 2 pages. Tells you everything you need to know. This is the baseband assembly. Come on, let's get to Chapter 5. In Chapter 5, which we'll be going over tomorrow morning at 9 o'clock, we will be covering the transmitter, receiver, order wire, intercom, and loopback testing. This is basically everything that I'm going to repeat on a slideshow and try to highlight certain areas where it gets you to understand it, and you can relate it back to the basic radio picture where it says transmitting baseband to the distant end and recover the baseband in those 3 steps. And I'm going to show you that, and also the branch assembly that comes into play also. So it just gives you an idea of what's going on. These are the electronic copies from the TO. You'll have the ones where it's, what do they call that? Landscape. This is portrait. Goes through the transmit side, then it will go through the receive side. Then you're going to have order wire. And we don't go through too much of the testing because it's all within the same circuitry. We just point them out to you. Any questions on the tech order? There's a lot of information in it. Be familiar where everything is at, please. The more familiar you are, yeah, you can do Control F, but let's just say that you're trying to do something that has to do with NRZ in the signaling format, and you type in, NRZ, and all of a sudden you got 500 of these. Figure out what you're asking for. Is it a characteristic of the radio? Is it in the schematics part of the radio in Chapter 5? What is it you're looking for? Figure out where that question is, or what the question is asking, and then target that area. Because obviously, if you're not looking for it in Chapter 1, you should be in Chapter 5, and then you can narrow it down. Just a hint. All right, we have a portion of for Charlie that we're going to go through real quick. Gosh darn it, what the heck over? All right, so we're going to look at identify basic facts about the characteristics of a Tropos satellite support radio, better known as the AN/GRC/239. We're going to be looking at covering the more detailed portion of the TISR. You're going to also deploy in Block 10. So in Block 7, we get you familiar with it and how to do the checks and everything else to make sure that it's working. When you get to Block 10, you have 15 minutes to set this up. And you're going, oh crap, we got 45 minutes to go to 15. There's a reason why. You're going to check this out in Block 10 before you deploy. You're going to put in all the frequencies. You're going to do all your checks. So when you get out to the deployed area, you're going to hustle your butt up and get that stuff opened up, installed, fired up, and transmitting. It's 15 minutes. You should be up and operational within 5 to 6 minutes. Just saying. You'll get a lot of practice. If not, you'll be doing it again. We're going to look at purpose, operating characteristics, types, traffic, equipment, and signal flow. We're going to hold on to signal flow in the morning. So the purpose, which is in Chapter 1, I think it's 1.2, says it's a full duplex line of sight radio. Full duplex meaning transmitting and receiving at the same time on 2 different frequencies. And you can go through the thing about easy to transport. Well, it's 3 cases, and all 3 of those cases are 2-person lifts. Short setup and teardown, that's when you get all the frequencies in and check it out prior to deployment. And reliable in adverse conditions, as long as you have the waterproof covers that goes on the front, as well as the ping pong ball that's covering the waveguide. Wow, this is an old picture, isn't it? BDUs. I still have mine in the closet. I can't fit in mine though. Yeah. You can see the frequency range, the power, the RIF frequency. Max range is when we have the 2 foot on there, less than 25 miles. 3 types of traffic: conditioned diphase, pseudo NRZ, and analog or digital voice order wire. There are 2 assemblies. There's the RF assembly and the baseband assembly that can be put on either the tripod or pole, but as far as that 2 foot dish, as far as the 1 foot dish, can only be put on the mast. And this is what one looks like in color. So you have the order wire, transmitter, receiver, breaker panel, and power supply. Again, 5 LRUs, line replaceable units, that's installed on this thing. There is 3 LRUs on the RF assembly, and you can see the thumb wheels that is in this picture. And you can see the 1 is embossed on there, and then it's either 15 or 14. You have the channel error light or the summary alarm, as well as the receiver pre-selector. Also see the meter, and you can go back and forth with it. You either have the 2 foot cable or the 1 foot cable. As always, the transmit and receive will be 200 megahertz apart. That's at frequency diversity. Shows you the difference between 1 and 2 foot antennas. Goes through how each one of them can be mounted, as well as the gain that's on it. So we're stopping here. Kind of surprised that it, wow, an hour, that's unusual. Normally it takes about an hour and a half. Is there any questions on this? Because this next step where we go through the transmit path or receive path, standby loop back, and order wire, that's a little in-depth, I should say, for tomorrow. Questions? Comments? Okay, so when we get off, I'm going to go ahead and upload both videos so you guys have a reference. Hopefully you'll use it to its fullest extent in trying to figure out what I had said, because I know this is a lot of information. Make sure that you're working on your homework, and we'll see you tomorrow at 9 o'clock. All right. You're welcome. See you tomorrow.